Hi guys, this is Mohammad P, a tutor on Chegg.com. Today we are talking about dot product and cross product. So let's just start with the two vectors. Vector v1 is equal to a1, b1, c1, and vector v2 it's equal to a2, b2, and c2. And we're going to find the dot product between these two vectors. So v1 dot v2 is a dot product, and it's defined as multiplying the corresponding components and adding all together. So I'm going to multiply these two together and add the result with the multiplication of these two, and then adding the result with the multiplication of these two. So it's going to be a1 a2 plus b1 b2 plus c1 c2. That's going to give us the result for the dot product between v1 and v2. There is another formula that you can actually obtain the dot product of v1 and v2. So that's basically this formula. So we have magnitude of v1 times magnitude of v2 times the cosine between v1 and v2, like this. So you can actually say this is a1 squared plus b1 squared plus c1 squared, and this is equal to a2 squared plus b2 squared plus c2 squared times cosine of theta. So that's going to give us also the dot product between two vectors. Sometimes the vectors they are not given by themselves, so just they are given they're giving you like the magnitude and the angle between them, and they ask you to find the dot product. So you use this formula to do that. If I want to do like a example, so let's say v1 is 1, 2, 3, and v2 is 4, 5, 6. And I want to find v1 dot v2. So that's basically 1 times 4, which is 4, 2 times 5, that's 10, 3 times 6 is 18. So that's going to give me 32, and that's a dot product between v1 and v2. Okay, now let's move on to the cross product. So the cross product is basically written like this, and it's obtained in two different ways. The first way is basically it's determined by the determinant of I, J, K, A1, B1, C1, A2, B2, C2. So because the result of the cross product is a vector, you need to calculate a determinant in terms of ijk that is going to give you a vector. So how you are going to do this? So I have I times negative 1 to the power of 1 plus 1, because the position of I is going to be first row and first column. So that's why 1 plus 1. And then if I cancel the first row and first column, I'm left with the b1, c1, b2, c2. That's a determinant obtained by canceling first row and first column. Then I go to j plus j, negative 1 to the power. This is the first row, second column, so it's 1 plus 2. Determinant of, if I cancel first row and the second column, I'm left with a1, c1, a2, c2. And then finally plus k, negative 1 to the power of first row, third column, so it's 1 plus 3. And then I'm left with the determinant a1, b1, a2, b2. So this determinant is basically obtained by canceling the first row and the third column. So if I calculate this, v1 cross v2, it's going to be, this is a 2 by 2 determinant b1 c2 minus b2 c1 I minus, because negative 1 to the power of 3 is negative, A1C2 minus A2C1 J, and then plus A1B2 minus A2B1 K. So that's the result for the cross product. As you see, it's going to be a vector. If you are only interested in the magnitude of the cross product, so you can use this formula. V1 cross V2 equal magnitude of the first one times the magnitude of the second one times the sine of the angle between them. Be careful. If you look at the dot product again here, the result that you get from either of these two formulas that I mentioned, they are both a scalar. So the result of the dot product is always a number. It's not a vector. But if you look at the cross product, as you see, here, this is giving me a vector, but this is going to give me a scalar. So that's why I put the magnitude, or basically the absolute value, to show that this formula only gives me the magnitude of the cross product, not the result of the actual cross product. Okay, let me show you an example for the cross product. So let's say the same vectors, so 1, 2, 3, and 4, 5, 6. Okay. I'm going to find V1 cross V2, and I'm going to find the actual result, which is a vector. So I have I, J, K, 1, 2, 3, 4, 5, 6. So I have I, the determinant of 2, 3, 5, 6, minus J. This is always minus J, by the way, because negative 1 to the power of 2 plus 1, that's going to be negative 1. So if I cancel first row, second column, I get the determinant of 1, 3, 4, 6. And then plus K. If I cancel first row and third column, I get 1, 2, 4, 5. So if I calculate this, I get 2 times 6, 12, minus 15. That's negative 3i. 6 minus 12, that's negative 6j, but there is a negative, becomes positive 6j. 5 minus 8, that's a negative 8, 5 minus 8, that's negative 3k. So that's going to give me the result of the cross product of these two vectors. If I'm interested in the magnitude of this, if I'm given the angle between them, I can use the other formula, which is this one here I already mentioned, that only gives us the magnitude. Okay, so I hope that you all enjoyed and you learned enough. So until the next video, I wish you the best and have a wonderful day. Goodbye.